Hi, I am B. Janardhan Reddy. In continuation of the previous video on the problems of series and parallel connection of resistors, I will show you some more problems in this video on finding the equivalent resistances when the resistors are connected in series and parallel manner. Here is the problem number 1. 4 resistors, each of resistance 2 ohms, are joined end to end to form a square ABCD as shown in figure 1.1. Calculate the equivalent resistance of combination between any two adjacent corners. So here is the problem figure. You can see here ABCD. Each resistor has 2 ohms resistance. So 4 resistors have been joined end to end to form a square ABCD, and we have been asked to calculate the equivalent resistance of this combination between any two adjacent corners. Let us calculate the equivalent resistance between the two adjacent corners, say A and B. Okay, so see here. Now I will extend wires here, this side and this side. If current is passed through this wire, it gets split into two parts. One of the parts of the current will pass through like this, and the remaining part will pass through like this. That means here between A and B, the two corners, here this resistor, this and this, these three resistors are in series manner because the same current flows through them. Okay, so let us go for the solution. This is the figure 1.1. Okay, solution. Let us find the equivalent resistance between the corners A and B. Between A and B, there are three resistors. 1, 2, 3, 3 resistors in the arms AD, DC and CB in series in one branch. That means between A and B, these two corners, the three resistors which are connected in the three arms AB, AD, DC and CB, these three resistors are in series, and the equivalent resistance of these three resistors is 2 plus 2 plus 2. It is equal to 6 ohms. That means we can replace these three resistors by single resistor of 6 ohms. Okay. Now one resistor, this one, 2 ohms, is in parallel with the equivalent resistor RS 6 ohms as shown in figure 1.2. See here, this is the figure. So if the equivalent resistance between the points A and B in figure 1.2 is Rp, you see here, I have replaced these three resistors by their equivalent resistor 6 ohms. Now this 2 ohms resistor and 6 ohms resistor are in parallel between A and B. Okay, so now 2 ohms and 6 ohms, these two are in parallel. So if the equivalent resistance between the points A and B in figure 1.2 is Rp, let us say it is a Rp, then we know that when the two resistors are connected in parallel, their equivalent resistance can be found by using a formula R equal to R1 R2 by R1 plus R2. Without taking LCM, we can calculate the equivalent resistance. So R is equal to R1 R2 by R1 plus R2, that is product by sum. So here Rp is equal to R1 R2 by R1 plus R2. So R1 is 2 ohms, R2 is 6 ohms. So 2 into 6 by 2 plus 6, we get 12 by 8, that is 3 by 2 means we get 1.5 ohms. That means the equivalent resistance of this combination between any two adjacent corners is 1.5 ohms. So you can calculate the equivalent resistance between the adjacent corners DC or BC or AD, we get the same answer as 1.5 ohms. Okay. Next, problem number 2. For the combination of resistors shown in figure 2.1, find the equivalent resistance between the points. First problem A, C and D, and second problem between the points A and B. So first I will show you the problem figure. So this is the problem figure. Totally 1, 2, 3, 4, 5, 6 resistors have been connected in this manner, and asked to find the equivalent resistance between C and D and between A and B. Okay, see here. If you want to calculate the equivalent resistance between the 2 points C and D, you see here, these three resistors R2, R3 and R4 are in series connection, isn't it? So we can replace these three resistors R2, R3 and R4 by their equivalent resistor 3 plus 3 plus 3, 9 ohms resistance. Okay, so here is the solution for this problem A. First, I am going to calculate the equivalent resistance between the points C and D. Problem A I am doing now. The resistors R2, R3 and R4 are in series. So if the equivalent resistance of these three resistors is Rs, then Rs is equal to 3 plus 3 plus 3. They can be replaced by an equivalent resistance Rs equal to 3 plus 3 plus 3. We get 9 ohms. That means these three resistors can be replaced by the single resistor of resistance 9 ohms. Then the first figure will take this form. Okay, so the resistance R5, this one, and Rs, just now we got 9 ohms, are in parallel between the points C and D as shown in figure 2.2. So this is the figure 2.2. Simply I have replaced these three resistors by their equivalent resistance of 9 ohms. Okay, now this Rs is equal to 9 ohms and R5 3 ohms. Again these two are in parallel between C and D. So we have to calculate the equivalent resistance of 9 ohms and 3 ohms which are connected in parallel between C and D. Okay, we have to use the same formula R1 R2 by R1 plus R2. If the equivalent resistance between C and D is Rp, why? Because these two are in parallel. For that reason I am taking the equivalent resistance as Rp. Then Rp is equal to R1 R2 by R1 plus R2. So here R1 is 9 ohms, R2 is 3 ohms. 9 into 3 by 9 plus 3, we get 27 by 12. So 3 fours are 12, 3 nines are 7, we get 9 by 4. This is equal to 2.25 ohms. So the equivalent resistance between the points C and D is 2.25 ohms. So this is the first answer. Okay. Now let us calculate the equivalent resistance between the points A and B. Just now we have found the equivalent resistance between the points C and D, and we got it as 2.25 ohms. Okay. We know that the equivalent resistance between C and D is 2.25. That means we can replace these two resistors by a single resistor of resistance 2.25 ohms. Now the resistors R1, RP, that is equivalent resistance of these two, and R6 are in series as shown in figure 2.3. See here, I am going to replace these two resistors because the equivalent resistance of these two, I got it as 2.25 ohms. Okay, now 3 ohms, 2.25 ohms and 3 ohms, R1, RP and R6, these are in series. So the equivalent resistance between A and B, RAB, is equal to 3 plus 2.25 plus 3, equal to 8.25 ohms. Okay. Next, problem number 3. Calculate the effective resistance between the points A and B in the circuit shown in figure 3.1. Here is the problem figure. So in between the points A and B, we have to calculate the equivalent resistance. Okay, so if current is passed from A to B, it gets split into three parts. One part goes like this, the second part like this, and the third part goes like this. That means same current flows through these three resistors. That means these three resistors are in series, as well as these three resistors are also in series. So 1 ohm, 1 ohm, 1 ohm. These three resistors can be replaced by their equivalent resistance 1 plus 1 plus 1, 3 ohms. So this circuit can take the form as, see here, I am replacing these three resistors and these three resistors. 1 plus 1 plus 1, 3 ohms. Again 2 plus 2 plus 2, 6 ohms. Okay. So here is the 3 ohms resistor I have connected in place of these three. Similarly 2 plus 2 plus 2, 6 ohms resistor has been connected. Now again these three resistors, 3 ohms, 2 ohms and 6 ohms, are in parallel. Okay, so these three resistors are in parallel. So we have to find the equivalent resistance of these three parallel resistors, and let us calculate it. 1 by Rp is equal to 1 by 3 plus 1 by 2 plus 1 by 6. Now let us take the LCM here. You can see here 3 is there, 2 and 6. If we calculate the LCM, let us divide them by 2. Take down 3 as it is. 2 1 is 2. 2 3s are 6. Okay. Next, dividing by 3. 3 1 is. Take down 1 as it is. 3 1 is 3. So if you multiply all these, 2 into 3, 6, 6 into 1, 6, 6 into 1, 6, 6 into 1, 6. So the LCM of these three denominators is 6. Now we have to divide the LCM by the denominator and multiply the quotient by the numerator. 3 2s are 6. We get quotient as 2. 2 into 1, 2. Similarly, 2 3s are 6. 3 into 1, 3. 6 1 is 6. 6 into 1, 6. If we divide 6 by 6, we get 1 only. 1 into 1, 1 here. So 2 plus 3 plus 1, we get 6 by 6 equal to 1 ohm. So the equivalent resistance of these three parallel resistors is 1 ohm. So I can replace these three resistors by single resistor of 1 ohm. See here, this circuit will take this form now. 1 ohm. The equivalent of these three resistors is 1 ohm. I have connected here, and here is 1 ohm. So between these 2 points A and B, the three resistors are in series, 1 ohm, 1 ohm, 1 ohm. That means RAB is equal to 1 plus 1 plus 1 equal to 3 ohms. That is the equivalent resistance between the 2 points A and B in the given circuit. Okay. Now, problem number 4. Calculate the equivalent resistance between the points A and B in figure 4.1. Here is the problem figure. A and B, figure 2.1. In this, 4 resistors have been connected in between A and B in this manner. Now we have to calculate the equivalent or effective resistance between A and B. So it's a very easy one. You can see here these two resistors are in parallel. If current is passed through this circuit from A to B and it gets split into two parts, some current flows through this resistor and some current flows through this resistor. So whenever current is getting divided, we can say that the two resistors are in parallel. Again, these two currents will join and flow like this. Okay. So we can replace these two resistors by means of a single resistance. Let us calculate the equivalent resistance of these two resistors. You know that when the two resistors are connected in parallel, we can find the equivalent resistance by using a formula. R is equal to R1 R2 by R1 plus R2, that is 2 into 2 by 2 plus 2. See here, Rp. Let us say the equivalent resistance of these two resistors is Rp, R1 R2 by R1 plus R2. 2 into 2 by 2 plus 2, we get to 4 by 4, we get finally 1 ohm. That means we can replace these two resistors by a single resistor of resistance 1 ohm. So at that time this figure takes this form again. That's all. So I have just replaced these two resistors by a single resistor of resistance 1 ohm. Now these three resistors are in series between A and B. So the sum of the resistances is equal to equivalent resistance. We know that. So RAB is equal to 2 plus 2 plus 1. We get 5 ohms. Okay. So that is the equivalent resistance between the points A and B. So here is the problem number 5. In the circuit shown below in figure 5.1, calculate the value of X if the equivalent resistance between the points A and B is 4 ohms. So here is the problem figure, and in between the points A and B, 4 resistors 4 ohms, 8 ohms and X ohms and 5 ohms have been connected in this manner, and we have been given the equivalent resistance between A and B as 4 ohms, and we have to calculate the value of X. Okay, so here is the solution. Given RAB, that is the equivalent resistance between A and B, we have been given as 4 ohms. Now you see here, if current is passed in this circuit from A to B, it gets split into two parts. Some current flows through like this in this branch, and some current flows through this branch. That means these two branches are in parallel. So here 4 ohms resistor and 8 ohms resistor, these two are in series. Again X ohms resistor and 5 ohms resistor, again these two are also in series because same current flows through them. So 4 plus 8, 12, X plus 5. So what is the resultant resistance of these two resistors? Here 12 ohms, here X plus 5. Now I am going to replace these two resistors by a single resistor of resistance 4 plus 8 equal to 12 ohms, and here I am going to replace these two resistors by a single resistor of equivalent resistance X plus 5 ohms. Then the circuit will take this form. I have replaced these two resistors by 12 ohms resistor, and I have replaced these two resistors by X plus 5 ohms. Now these two resistors are in parallel between the points A and B. So when the two resistors are in parallel, we have to calculate their equivalent resistance by a formula. R is equal to R1 R2 by R1 plus R2. RP, that is the parallel. RP is the equivalent resistance in parallel. RP is equal to R1 R2 by R1 plus R2. Let us put these values in this formula. See here, R1 equal to 12 ohms, R2 equal to X plus 5 ohms. 4 is equal to, because we have been given RAB as 4 ohms, isn't it? The resistance between the equal resistance between the A and B is 4 ohms. R1 is 12 into R2 is X plus 5 divided by R1, 12 plus R2 X plus 5. R 4 is equal to 12 into X, 12X plus 12, 5s are 60, and 12 plus 5 we get 17, X plus 17. Let us take cross multiplication. If no denominator is there for this, you can take it as 1. Take the cross multiplication like this, isn't it? You see here, 4 into X plus 17 equal to 12X plus 60. Otherwise 4X plus 68 equal to 12X plus 60, or we can write it as 68 minus 60 equal to 12X minus 4X, or 8X is equal to, we get 8. So 8 gets cancelled, we get X equal to 1 ohm. Okay, so that is the equivalent resistance between, not equivalent resistance, this is the value of X, that is of these 4 resistors, the value of one resistor hasn't been given to us, that is X value we have calculated. Okay, X is equal to 1 ohm. Thank you.